Saranya Chejalla. Welcome to ECB Tech. Today in this class we are going to learn about one of the main important concept of data link layer is sliding window protocols. It is another type of protocols. See, the actually the data link layer divided into two types of protocols. Let's suppose two types of protocols. The first one is elementary data link protocols and the second one is sliding window protocols. Right, in the previous session we discussed elementary data link protocols. In this session we are going to learn about another thing, sliding window protocols. Let us get into the topic. And what is the sliding window protocol, what is the purpose of this, and what is the use of this particular type of protocols in the network. Okay, let us get into the topic. Right, see, sliding window protocols. The sliding window protocols are those protocols that used a method of flow control in networks for the transfer of data. That use a method of flow control in networks for transfer of data. So by using this protocol, we can control or we can manage the data flow in the network while transferring the data from source to destination. See, this is one type of technique. The sliding window is one type of technique that multiple frames can be sent at a time. The multiple frames can be sent at a time. And here, before receiving each frame acknowledgement, we will receive one acknowledgement of multiple frames by the receiver. One acknowledgement of multiple frames by the receiver. See, in this, whenever I want to send a multiple frames from source to destination, I'll send that particular frames to destination, and the destination or the receiver give these only one acknowledgement frame for these multiple frames. Only one acknowledgement frame for these multiple frames. Here, sliding window. Sliding window means it is a one specific size of window. One specific size of window where the frames are numbered as n, and the simply means number means 0 to n minus 1. Whenever the receiver sends an acknowledgement, it also includes the number of the next frame. Here, whenever the frames in the window, the sliding window, the window will contain n number of frames, means the window will contain n bit, the frames will contain n minus 1. The window will contain n bits. Listen clearly, the window will contain n bits and the frames is a 0 to n minus 1. N minus 1. Right? See, here, whenever the receiver gives an acknowledgement frame for multiple frames what they received from the sender. Okay, it also includes the number of the next frame that he want to receive. This is the concept of sliding window. See, this is one type of technique to send multiple frames from source to destination at a time, and will receive only one acknowledgement frame instead of number of acknowledgement frames. And here we are maintain one type of window, that is nothing but a sliding window, and the size of the window is n, and the frames that consist of that window is n minus 1. Okay, see, at the center side we will call that window is a sending window, and receiver side we will call that window as a receiving window. Okay, right. What are the steps we have in a sliding window for sender side? See, uh, point wise we have the particular steps that follow the sender by using this sliding window. To keep the track of frames, the sender station sends a sequentially number of frames. Means in the sequential manner, in one particular order, the frames will be sent from source to destination. The frames will be sent from source to destination. Second point, if the k bits are allowed by the header of the frame, then the sequence number of ranges from 0 to 2k minus 1. If the k bits are allowed by the header of the frame, then the sequence number ranges from 0 to 2k minus. Here, first step, we read that there is one sequential number will be assigned to each and every frame. Each and every frame, right? Whenever and that particular frame contain a k bits, the particular frame contain a k bits and that sequence number ranges from 0 to 2k minus 1. 0 to 2k minus means, for example, if a frame consists of 10 bits, let us see the one example. If the frame consists of 10 bits and the sequence number ranges from 2 into 10 minus 1, 20 minus 1, 19. 20 minus 1, 2k minus 1. Okay, and the size, the third point, the size of the sender window is at most 2k minus 1. The size of the sender window is at most 2k minus 1. Okay, for example, see, 4 bits are allowed by the frame. Here another example we are taking, 4 bits are allowed by the frame, then the size of the window is 2. Then the size of the window is 2 power of 4. 2 power of 4 that equal to 16. I will show you diagram, right? So it will get clear order. See, this is a sliding window. It will contain, okay, 4 frames. Okay, 4 frames that equal to n. This is a sample example. This 4 is a sample example. Okay, this is a sliding window sizes. Next, how many bits? How many bits will be there? How many frames? Bits means frames. How many frames will be there? This particular window means n minus 1. N minus 1 that equal to n minus 1 means 2 power of n minus 1, actually 2 power of n is 4 minus 1. 2 power of n minus 1, the actual frames. So 2 power of 4 means 16 minus 1 that equal to 15. Okay, so this n indicates the size of the window wherever 2 power of n minus 1, 2 power of n minus 1 indicates the what are the frames inserted in that particular window. Okay, so this is the actual procedure. We take an example 4 here. So in the place of n, I take the 4. Okay, 2 power of n minus 1, 2 power of 4 minus 1 that equal to 16 minus 1 equal to 15 bits or 15 frames. Right? Okay. Next, see the last step. The buffer is provided to the sender that has the size equal to the size of the window. Here, buffer concept will be appeared, right? Buffer means each and every sliding window what contains an buffer, means the sender side sliding window contains an one buffer and the receiver side sliding window contains an another buffer. So what is the main role of buffer means, the particular data will be stored in that buffer only. The particular data will be stored in that particular buffer only. Means whenever the sender sends the particular data frames to the receiver, multiple data frames to the receiver, so from 4 data frames at the buffer it will take 4 data frames will be received, will be sent to the particular receiver, and the receiver will give acknowledgement what they sent 4 frames from sender side, give that acknowledgement frame that particular 4 frames, and it also includes what he want to receive next frame. next frame number. What he want to receive next frame number will also include that particular acknowledgement frame. So this is an sender side and receiver side. The size of the window is receiver is always 1, because here receiving, whenever the data is received, then only the particular window is moving. Okay, so acknowledgement of the frame is done by sending an ACK frame by the receiver to the sender along with the sequence number of next expected frame. We already discussed in the previous. Whenever the frames will received by a receiver, only one acknowledgement frame will be sent by including that all frames, and he also include one sequence number of the next expected frame. What he want expected frames for next time, that will be that sequence number will be included in that particular acknowledgement frame, right? And this scheme is used in order to acknowledge multiple frames. Yeah, in order to acknowledge multiple frames. For multiple frames, we send only one acknowledgement frame, that the receiver send to the sender. The window at the receiver side can hold, for example, 2 3 4 frame, but holding the ACK frame until the frame 4 has arrived. Here, the sender want to send 2 3 4 frames, multiple frames, 3 frames, but the acknowledgement frame will be hold until he receive all the frames from sender to, all the frames by the sender, until he receive all the frames what the sender sent, 2 3 4. After receiving the last frame or fourth frame, then only the acknowledgement frame will be sent to the sender, including the sequence number of next expected frame, including the sequence number of next expected frame. Here the buffer side is needed by the receiver is 1. I already said sender side also we have a one buffer, and the receiver side also we have another buffer. Here sender side, the buffer size equal to the size of the window. Receiver side, the buffer size is needed by the receiver is 1. Here the size of the window is also 1, the buffer size is also 1, right? The receiver side, what they are doing means, whenever the sender sends the frame, it will receive each and every frame. After multiple frames what he received, then only the acknowledgement, the particular acknowledgement frame will be sent to the sender. And this is the process. Let us see the diagram here. We have a clear idea about a sliding window protocol. So this is an sender side and this is an receiver side. This is an sender side and this is an receiver side. Sliding window protocol. Sliding window. This is an sender side sliding window and this is an receiver side sliding window. See, we have a buffer. You can call this is an buffer or sliding window. The first 4 frames I am sending. The first 4 frames I am sending. Here, whenever the frames are received by a receiver, okay, here see we have a sliding window directions. Let us observe the directions here. This particular window will move, the left side window will move. This was moves to the right. From left to right, the sliding window moves. Whenever the frame received, this window will move left side. Whenever the acknowledgement is sent, the right will move. The right side window will move. Okay. So let us see. I sent in 4 frames here. 4 frames here. And the next step, I give an acknowledgement only the multiple frames, 2 frames, and 3, 4, 5, 6. Another frames also I am sending. I need an acknowledgement for these frames also, and these frames are not yet sent. Okay. So here only the window showing these particular frames means we get an acknowledge for these all frames, and we need an acknowledgement for these frames. These frames are sent to the receiver. These frames are sent it to the receiver. This is a sliding window. From left side to right side, it will move. From left side to right side, it will move. Okay. So, whenever here, the only one concept between sender and the receiver means it will move from left to right. From left to right. The sliding window will move from left to right. Whenever this is an left side and this is an right side, right? So this will move whenever the sender gets an acknowledgement of for that frames, it will move from left to right. In this receiver side, whenever the particular frames are received, it will move from left to right. That is a simple difference of a sender and receiver. This is a sender type sliding window and the receiver's type sliding window. Okay. See, next, in the sliding window protocols also we have a different types. So, one bit sliding window protocol. One bit sliding window protocol means only we are sending an one frame at a time. Only we are sending an one frame at a time. I will show this example also. I will get a clear idea. So see, this is a sender side sliding window and this is this receiver side sliding window. Here I am not sending, I am ready to send one frame here. I am ready to send one frame, that is an 0. It is in ready state. Here receiver wants to receive this particular 0 frame. This particular 0 frame. He is in ready state to receive that particular 0 frame in that time. See, initial stage, the size of sending window is 0, the receiving window is 1. Initial stage, the sending is an initial stage will be considered as 0 and the receiver stage will be an 1. Okay, he are ready to receive that particular thing. So, second step, the first frame has sent. The first frame has sent. Whenever the first frame has sent, when this particular receiver will receive it, the sliding window moves from left to right. The sliding window moves from left to right, so it indicates the one. See, whenever I send a frame here, 0 frame, the receiver received. Okay, so when he received the particular frame, it moves to the 1. It moves to the 1. So here the particular window is in 0 means he have to give an acknowledgement to the sender. The receiver have to give an acknowledgement to the sender. See here, after the first frame has been received, the acknowledgement has been received by that particular sender. So after receiving that particular acknowledgement only, it will move from left to right. It indicates 1. Okay, so in this acknowledgement, the receiver sent that he received an 0 frame. He want to receive a next frame 1. 1 means that is the sequence number of the frame. I already said the receiver will give an acknowledgement frame of multiple frames, which includes the next expected frame sequence number. Next expected frame sequence number. So this is an one bit sliding window. Whenever the particular frame is received by a receiver, the receiver will give an acknowledgement to the sender with included of next expected frame 1. Then the sliding window moves when the receiver in this receiver state, the sliding window moves whenever the particular frame received. In that sender state, whenever the acknowledgement received, then only the sliding window moves from left to right. Okay, so this is about an one bit sliding window. Only one particular frame will be sent at the time. Next we have another model is Goback and Arq. Arq stands for automatic repeat request. Automatic repeat request. So what is the purpose of this sliding window? See, the Goback and Arq protocol is known as Goback and automatic repeat request. Okay, so it is a data link layer protocol that uses a sliding window method. Sliding window method it is using. If any frame is corrupted in this particular sliding window, if any frame is corrupted in this particular sliding window, all subsequent frames have to be sent again. So here, whenever the frames are sending from source to destination, after sending one frame, it will receive one acknowledgement. After receiving that acknowledgement only, then he will send another frame. Okay, this process will be going to like this, but here the only drawback is whenever the one frame is corrupted while sending the frames from source to destination, the next frames who are ready to send, that frames will be also sent again. Here the corrupted frame will not accepted by the receiver. While sending the frames from source to destination, if any frame is corrupted during transmission, the corrupted frame will not receive it by the receiver. Again, from starting onwards, the subsequent frames will be sent by an sender to the receiver. That is the concept of go back. And see the diagram here, you'll get a clear idea about mm, an go back and protocol. See, this is an sender and this is an receiver. Okay, we have a frames sliding window. This is a sliding window moving. Whenever the frame 0 is sending, in this window frame 0 is sending, see, frame 0 is sending, I'll get an acknowledgement. Whenever acknowledgement is come from the receiver, then only the window moves from left to right in a sender side. See, it shows, it indicates to 1. Next, frame 1. Frame 1 I'll send, but I frame 1 I'll send. The receiver give an acknowledgement, but the acknowledgement is lost here. So whenever the acknowledgement comes to the receiver, then only the window moves from particular that frame to another frame. Again, when the particular acknowledgement is not received by the sender, again the frame 2 is sent. Okay, he didn't get acknowledgement of an frame 1. Again frame 2 is sent. The acknowledgement will be given to frame 2. After frame 3, acknowledgement will be given. Here subsequent frames will be sent, means whenever here one acknowledgement is lost, that is the receiver side. Whenever the sender side frame is lost, all the subsequent frames, what is there in the particular sliding window, that will be sent again. Okay, so this is the concept of go back. And when here there is no corruption of frame, right? When the frame is corrupted, the particular receiver will not accept it. That frame. Here, which one is lost? Acknowledgement is lost. What the receiver provide an acknowledgement to the sender, that acknowledgement is lost. Okay, whenever the frame is corrupt, particular the frame one is corrupt, is not sent, is not received by that particular receiver, the subsequent frames from starting onwards, the subsequent frames will be sent again. Okay, this is the process of an go back N. In this, must and should remember this point. The receiver will not accept the corrupt frame. Whenever the frame is corrupted, while from sender to the receiver while transmitting, the frame is corrupted, the particular subsequent frames what is there in that sliding window, all will be sent again. All will be retransmit again. Okay, this is the procedure of go back N. Here there is an one disadvantage of go back and so this particular protocol is suitable when there are few errors in a channel. Okay, suitable when there are few errors in a channel, but for large errors it is not a suitable, it is not a flexible to use this type of protocol for flow control or error control. Okay, so for that we have a next type of sliding window protocol, that is the selective repeat. So go for that. So see, okay, in go back, the go back one works well, but the only thing is if you have few errors it works very efficiently. A lot of errors in the frame will occur while transmission. It is not that much flexible because there is a waste of time to send the frames again, for that sake. For that sake, we introduce another type, selective repeat ARQ. Selective repeat ARQ, automatic repeat request. So it is one of the data link protocol that uses the sliding window method. This is one type of method. In this, in this, the receiver receives the corrupt frame. The concept of selective repeat is the receiver receives a corrupt frame, but it does not directly discard. It receives the correct frame, but but the receiver does not directly discard. He gives a negative acknowledgement what he received the corrupted frame. He gives the negative acknowledgement to the sender what he received the corrupted frame. That is the concept of selective repeat. So when the negative acknowledgement will send to the particular sender, the sender will again retransmit that particular frame only. So in this time there is no waiting stage will be there. Okay, and there is no time delay in this particular protocol, and it is very efficiency protocol for large when a lot of errors occur in the frame during the transmission from source to destination. Let us see the diagram also, how the frames are delivering from source to destination, uh, how we can retransmit that particular corrected frame, the particular receiver given negative acknowledgement. Let's see the process of selective repeat automatic repeat request protocol. So this is a selective repeat concept. See the diagram here. Okay, so this is also using a sliding window method. Sliding window method. So the window shows the first multiple frames up to 0, 1, 2, 3. I am sending the frame 0 here from source to destination, and this particular frame is received by an receiver, and he give an acknowledgement. Okay, so when the acknowledgement came, the window moves from left to right in the sender side. So it indicates the 1. Again the frame 1 I am sending here. Here this not arrived or delivered to the receiver. Delivered to the receiver, he is waiting, and again it does not have any acknowledgement. Again frame 2 has sent. Frame 2 has sent. So he got a negative acknowledgement for frame 2. Okay, frame 3 has sent. So here see, uh, slightly he is delivering the frame 2, frame 3, and he, the receiver, sends the negative acknowledgement of 1. See, negative acknowledgement of 1. Negative acknowledgement of 1 means the frame 1 has lost and I didn't receive that particular frame. I didn't receive this particular frame. Then the particular frame will be resent. The particular frame will be resent, and he the frame 1, 2, 3 is delivered. The frame 1, 2, 3 is delivered, and for multiple frames he given one acknowledgement. For multiple frames he given one acknowledgement. Okay, this is a sliding window process. I already said multiple, we can send multiple frames at a time. We can send multiple frames at a time. For multiple frames we receive one acknowledgement. In this concept, while sending an frame 0, I receive an acknowledgement immediate. Frame 2, frame 1 I didn't receive an acknowledgement. I send the frame 2, frame 3 also, and I get a negative acknowledgement of frame 1. I will select that particular frame, and I will send again. I will get an last and final acknowledgement frame of all delivered frames what he received by the receiver. What he received by the receiver. Okay, the selective repeat is a very very important concept and very very efficient protocol for large number of errors occur in the frames. So this is an sliding window protocols. So the sliding window method is to deliver a multiple frames at a time from sender to the receiver into the network, and instead of receiving each frame acknowledgement, only one acknowledgement he received for multiple frames. Okay, so this is the concept of sliding window method, and we see that different type of sliding window protocols. We have one bit sliding window protocol, go back and sliding window protocol, and selective repeat protocol. So go back and is used for one bit sliding window protocol means we send only one bit at a time. Go back and means for fewer errors it is suitable, for large number of errors it is not suitable. For that to remove that particular, to eliminate that particular thing, we introduce another thing is selective repeat, automatic repeat request. That means only the selected frame will be resend it again. Okay, so this is about and sliding window protocols. I hope you understand. Kindly like, share, subscribe easy btech for more videos. Thank you.